everyone, welcome back to another video. In this video we're looking at, or we're continuing to look at, finding the shear force, or creating a shear force diagram, creating a bending moment diagram, and this will all be done using the graphical method of space diagram, polar polygon, and funicular link polygon to determine both shear force and bending moment. So let's get into things. From our previous video, you'll understand what we meant by scaling. What this is saying for every 1 meter in real life, it is going to be 1 centimeter on our paper, which is our drawing environment here. Scale in relation to the load. For every 2 ton, it will be equal to 1 centimeter on my load line. And if you have watched the other video, if you haven't watched that video already, go ahead, watch that one, and then come back to this one here. So let me go ahead and shift these to the side of it. Alright, so because we have already drawn our free body space diagram here already, we can now get into things and start things off by drawing our polar polygon. And we'll do so by first drawing our load line that will represent our 5 ton here. I'm assuming that is T mean ton, 12 ton, and 10 ton. Alright, so let's draw our lines to scale, or our load line to scale. So we're going to start off by first drawing our 5T line. Now for every 2T, it's going to be equal to 1 centimeter. So in this case, it's going to be equal to 2.5, I believe. So let's go ahead and draw that line, vertical line, 2.5 centimeter. Alright, so that's the first line. Then the second line is going to represent this 12T. The 12T is going to be equal, so 12 every 2 ton is 1 centimeter. So in this case, it's going to be equal to 6 centimeter. Alright, and then now finally the last one, which is this 10T, which is going to be 2. So in this case, it's going to be equal to 5 centimeter. Alright, let me change the color so you can see. Alright, there we go. So that's our load line. There. Now point A, B, C, and D. You can go ahead and label them as well. I'm going to go ahead and I'm going to identify my point O, which is our pole over here. And we're going to go ahead and connect with lines. So from point A to, let me change my line type, this white one here, to point O, then back here, then again continuing from here to our point right there, and then back to that location there. So let me just go ahead and just add some labels before we move along. So let's copy this one here and add my labels. So we have here, I'm going to write that one in. This point A, and let's copy it down. And let me snap that one there. So that will be point B, point C, and point D. And let's move over to point O over here. Alright, so let's double tap and edit these labels. So this is point O, continuing, so this is point B and point C, and then finally we have point D, which is right here. Alright, so now that we have our load line in place, alright, we can now go ahead and we can create our funicular link polygon to determine our bending moment. Alright, so let's go ahead and project our lines down. So I'm going to go line, enter, and from everywhere there is some form of force acting, I'm going to project a line down. So for example, this one here, and I'm making my lines extra long this time around. Alright, so let me zoom in so you can see. So we have a force acting down right here, one acting down right there, we have one acting down right here, and then we have RR acting up right there. Alright, so first thing we're going to be doing is that I'm going to be projecting lines across from this point here. So for example, I'm going to be projecting lines from point A here. I'm just not going to start here, but I'm going to use dynamic tracking to assist me with this. So I'm going to be using dynamic tracking to assist me. So from here to here, and I'm going to be doing so from all the different points. And I'm kind of jumping the gun here with what I'm doing, but I want to do this so I can have a visual representation of where I stand in relation to everything else. Alright, then from point D here. Alright, so in this space here is where I'm going to place my shear force diagram. Now, if you remember my bending moment diagram video, you realize that I have not done that as yet, and I'm going to be doing it somewhere down here. Alright, so I'm going to be doing it somewhere down here. Alright, so right here will be my point X, starting at my point X. So let me go ahead and copy this letter right here and then place it right there where my point X will be starting, right here. So here we have our point X right there. Alright, so let's now make our way around. So starting here, AO, I'm going to copy AO, and I'm going to place it where? Right there. Hopefully everything is alright. It's not snapped to the right location, so I'm going to be moving it. So I move it from here to there. Alright, so now it's at the right location. You'll notice that the line extends beyond this line here. So I'm going to trim away the excess. I might have to add that back later on. Then now I copy point BO. Continuing with the head and tail fashion, it's going to be placed right here. Alright. Then now you'll realize that it extends beyond this line. So we trim away the excess. We continue the process. The next one is CO. So we copy CO. And we're going to place it right here. Alright, so CO is, let me move CO correctly down. Alright, so you realize that CO does not touch this line here. So what I'm going to do is that I'm going to extend it so that it touches the location. Then finally, we have DO. So we're going to copy DO, CP, and we're going to place it right here. Alright. Alright. So based on how things are now, it seems as if it will be interfering with my shear force diagram. So what I'm going to be doing, after I've trimmed away the excess right here, I'm going to be shifting things down a bit. So I'm going to select everything here, and I'm going to move it down just a tad like that. Alright, now I'm going to label my point Y. So let me copy X right there, and I'm going to place it, turn ortho off, and place my point Y on this side here. Alright, so that's my point Y, and remember we connect point Y to point X. So let's go ahead and add that point. So point Y and point X, and let's add that one to that there, just like that. So now we have our EO line. Alright, so we're going to now copy our EO line, and we're going to place it where? At point O right there. And again, remember it extends beyond this line here, so I'm going to trim away the excess. So we now have our EO line. So let me copy this here, and I'm going to place right there. And this point here, now where it touches the load line, is your E point. Alright. And this line here now is your EO line. Let me copy this one here, and I'm going to label my point. So this line here is your EO line. That's your EO line. Alright, we have our XY line. This is our AB line, or BC line, I believe. Alright, so here we go. So once that has been done now, again, we connect these two end lines. Alright, so remember, we're going to be using the fillet tool for this one here. So we fillet this one here and this one here. Wherever those two lines intersect, wherever those X and the Y line intersects right there, basically these two lines, we're going to be stretching a line all the way from there to touch our free body beam here. Alright, let me go ahead and paste this on the relevant layer. And remember, this is your equilibrant line. Over here I'll have a text already, so I'll copy this text over to represent my equilibrium line. Alright, so let me not snap to anything right there. So this is your equilibrant line right there. Let me shift my EO annotation to the right a bit, just like that. So as you can see, we have our bending moment diagram there. Let me add some labels. So down here we have our bending moment. Let's go bending moments diagram. So we have our bending moment diagram. We scale this down a bit to 0.4. Alright, so we have our bending moment diagram here. Alright, and we're going to be creating our shear force diagram now. Our shear force diagram is going to be up in this area right here. Again, remember that this is your link polygon in the middle here. So if you want, I can add a text to represent that. So here, this is our link polygon. Let's go, link polygon. Alright, so we have our link polygon there. Again, this over here is our polar polygon. Now in your exam, they might ask you to do different things. They might just ask you for the bending moment diagram, or just the reaction, or just the shear force diagram, and you'll do accordingly. Alright, so this here is your polar polygon. Alright, right there, that's your polar polygon, and we're now going to be doing our shear force diagram. Now you will recall me projecting lines across from these points here. Alright, the only one that is missing now is your EO line, your horizontal EO line. So we're going to project a line across now to represent that there. So for example, from E right here, and project the line across. Let's ensure that I'm snapping to the right thing. Alright, so now I can project my line across. So that's your O line right there in the middle. Alright, now it's time for us to create our polygon. Well, not our polygon, our shear force diagram. So let me go ahead and I'm going to select another layer so I can represent it right there. So starting at point A right here, alright, I'm going to go across horizontally until I get to the load. So I know that once I get to the load, that force is acting down. So I drop down to where it stops. Where does the load stop? It stops at point B right there. Here is point B running across horizontally. So that's where it stops. Then again, the force, nothing is going on. Alright, so I continue straight. Once there isn't any force acting, then it's going to be straight. So it's going across straight until it gets to that 12 ton there. Once it gets to that 12 ton, I know what happened. The force drops down. Alright, force is acting down. So what do I do with my cursor? I move downward with my cursor as well. Alright, and it goes all the way to where? C. That's where C is. And here C on the horizontal. C on the horizontal is right there. Now nothing is happening after that until it gets to where? The 10 ton. Once it gets to the 10 ton, then the force starts acting again. So it what? It drops down. Alright, so once there isn't a force, then it means that the line is going horizontally. Once I get to where a force is acting down, then I drop the line. So it's going all the way down until it gets to point where? D. And here is D right here. Alright, now nothing is happening, so it's going across until it gets to the end here, which is RR. What is happening at RR? RR force is acting up, so it is going to go all the way up until it gets to your EO line. That's this line here. That's your EO line there. Right, and it runs all the way across to where? RL. Alright, once you get to RL, what is happening? The force is acting up in the air, so it means that you need to draw your line going up like this. Alright, so as you can see now, we have pretty much completed our shear force diagram. Now you can go through and you can label your points. So let me grab onto this here, and so you can see what I'm talking about. So here is A, alright, and all the way till it gets to here, yes, it's A as well. Alright, then what is happening here? Alright, because that is representing this here. So we're now at B. So it drops down to, where does it drops down to? It drops down to B, and B runs all the way to this point here. Alright, that's where B drops, and then afterwards it drops down all the way to where? C. So C is right here, so I'm going to copy C. So C is right here, and C runs all the way to this point here before it drops down to where? D. So D, and once it gets to the other D right there, it moves up all the way until it gets to where? E. And then E goes all the way, nothing happens until it gets to E on the other side. And then once it gets to E, it goes all the way up there. Now if you want a better visual of this, this is what I'm going to be doing to show you. I'm going to go ahead and I'm going to hatch this entire area where the shear force is acting. So this solid color here, just go ahead, click, 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 and click. And that is your shear force diagram. Again, reactions are calculated the same way in which we did it in the previous video. We add the forces, we multiply the forces, and we find our missing values. And there you go. We have found the shear force, alright, on this beam here. So now, if you're ever wondering what the shear force is, now the shear force is the difference basically between the upwards and the downwards force that are acting together on a beam. So it's the difference between all the forces here that are acting down and all the forces that are acting upwards. The bending moments now is a bit different. Now the bending moments is basically the force that is required to maintain equilibrium. Alright, basically the force that is needed to cancel out the forces that are acting. So basically the force that is required to be acting up to cancel out all the forces that are basically acting down. Now if you found this video helpful, don't forget to go ahead, leave a like, share, and subscribe. Don't forget, again, share with your friends, and I'll see you in the next one. And if you need lessons, don't forget to reach out to me. Alright, see you in the next one.